Hello friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2596. Check net Tor configuration. In this video, we're going to share a solution based on direct check. So first, let's roughly look at the problem statement. So there's a knight on an n by n chessboard. In a valid configuration, the knight starts at the top left cell of the board and visits every cell on the board exactly once. So we are given an n by n integer matrix representing the chessboard. So here the matrix is called grid. So it consists of distinct integers from in the range 0 up to n squared minus 1. So this is a closed interval. So also notice that the move of knight is all the moves are 0 indexed. So we are required to check if the grid represents a valid configuration of the knight's movements or false otherwise. So here is an important note which defines what's a valid configuration. So a valid knight move consists of moving 2 squares vertically and 1 square horizontally, or 2 squares horizontally and 1 square vertically. So here is a possible movement. This is the main problem statement. So here are 2 examples. So in example 1, so for example the return is true. So you can start from here, then to this 1, and then to this 2. So then to 3, like this, or like this if you like. So anyway, this example demonstrates a good configuration. For this one, this you can move from here to from 0 to 1, and then to 2, to 3, to 4, to 5, to 6, and then to 7. But 7 and 8 are next to each other, so you cannot move using valid movements. So this returns false. So here are the constraints. First, n is the size of the square grid, and n is in between 3 and 7, and the grid elements is from 0 up to n squared minus 1. I guess here is strictly less. So all integers in the grid are unique. So this is an important one actually. So with that said, we are ready to do the coding. So for the coding, we are going to present 2 formats. So both are direct check treatment. So we are going to use direct check. So you can use a for loop, or you can use a while loop as we like. Here first, I'm going to do a more verbose check, and then we do slight refinement. So this is our plan. So let's first do a brute force check. So in this first solution, so here we want to do a verbose check or brute force check. So this actually might be the way most people do this problem. First, I'm going to track the size, length grid. So notice that for this grid, it's a square grid, so the number of rows and number of columns are equal. And then due to the way of the valid movement, so we can know the move right direction. So we can move from the current x and y. Let's see, this is a coordinate. So you can go to next coordinate x plus dx and y plus dy. So dx dy should satisfy the pattern in the note. So for convenience, let me write these directions. So here I'm going to use a list. So here we have 2, 1, means that horizontally move 2 and vertically move 1. So 2, negative 1. This is also a possibility. Or we can change to negative 1, negative 2, positive 1, negative 2, negative 1. So you can do this. And also, if we move x horizontally just by 1 and then vertically by 2, so we have 1, 2, 1, negative 2, or negative 1, 2, negative 1, negative 2. So this list consists of the number of valid increments of coordinates. And then basically we want to do the check. So first I'm going to initialize a step. So this step actually is which step we're in. So it's also equal to expected value, right, in the cell. For example, at the starting point, that's going to be a value 0. Then at next step, that's going to be a value 1. So let's write current x and current y. So it should be at 0 and 0, right? So this is the start position. So next, we're going to use a while loop to incorporate the logic. So while true. What we are going to do, we are going to check if step equals n squared minus 1, and grid the current position, current x, current y, equals to step. So notice that this also implicitly checks the starting position, right? So current x and current y equals, if this is at 0, so we need to make it equals to 0, right? If this is the case, we're going to return true. Means that we have finished the procedure and finished the check. Next, we want to see if we can from the current position, current x, current y, to move to a valid next position. So here, let me first use a font to be false. So currently, we want to see according to this directions if we can move to next position with value 1, right? So here, basically, this is sort of verbose because we need to check, in principle, 8 positions, 8 possibilities. So basically, for dx, dy in directions on this list, and then the new x will be current x plus dx, and y will be current y plus dy. Then what we need to check that we want to make sure this x is inbound and 0 less than or equal to y less than n. So this is the inbound condition. If inbound, we're going to check if grid x and y equals step plus 1. So this is the value it is supposed to be. If so, we found we change the flag variable, and then we are going to increment the step by 1, and then we set current x, current y to be the new position x and y, right? Then just a break, we do not need to check anymore because the values in the grid are unique, right? So this is the one, and then after this for loop, if we still not found the next position, so we're going to return false. So this forms one solution format to this problem. So before we move forward, let's do a check first. Yeah, it passes one example. This, I guess, is example 1. Now let's look at the generic case. Yeah, it passes all the cases smoothly. So this is the version we want. Let me copy this part. Let me copy this part code, and then we're going to change this one to be version v1, and then we are going to do some slight refinement. So here I'm going to check reversely. So basically I'm going to check from the current position to a previous position. I want to check if their difference is inside this roughly this dictionary. So this is what we're going to do. So now let's first delete this part, and then n is kept. So I want to make this direction a dictionary. So this is for convenience of membership check. And then we cannot use list anymore because list is mutable or non-hashable. So I'm going to change this to be tuples. So tuples is immutable or hashable in this for this purpose in the set. So we put this hashable objects in the set, right? So this is a preparation component or step. Once we've done this, let's also comment out this. And then what we are going to do is that first I'm going to find the positions. So the positions is going to be this. I'm going to use a list comprehension RC or XY grid, and then we're going to use this RC for R in range M, for C in range N. So notice that the role of this one is also for convenience of membership check or key value check here. So we have this directions, and then we have this positions. So this one is very important. Actually, we don't need to sort according to the grid value in order to get the order of the coordinates. We just use a dictionary. So this is the one part. And next, we want to check if position 0 does not equal to 0, 0. Because one of the prerequisites is that, so to be valid, we need to start from this coordinate. If it does not, so we're going to return false. Then otherwise, we just need to do the check. So for I in range 1 up to n square, right? So this iteration of for loop is n square minus 1 rounds. So this I is also should be the current value, right? Then RC, let's get or XY as position I. So this is the current position. Then R previous, C previous equals position I minus 1. Because we are starting I from 1, so I minus 1 is greater than or equal to 0. So it's a valid index. So we get the current position RC, we get the R previous and C previous position. And then in order to be a valid move from this previous position to the current position, we want to make sure their difference as a tuple should be in this set. That's the way we do the check. So this way, we just need to do a membership check. So basically, if R minus R previous, so C minus C previous. If this in directions, let's use the other. If not, it means that it's not. We cannot move from the previous position to the current position. We're going to return false, right? So this is the one thing. Another thing is that we also need to make sure the value is right. So grid RC. For the current position, it should be equals I, right? If it does not, so we're going to return false. Then after the for loop, if nothing has returned, so we're going to return true. So this forms another solution format. So overall, we need to iterate the grid. So basically, it's n square, right? N is the length of the size of the grid. So let's do a check first. Yeah, it passes one example. No, this is the generic case. So that's about it for this specific problem. So here we provided two slightly different or similar solution formats. So the first one is more verbose, and the second one actually we do a check in sort of reverse fashion. So we are going to recommend the second method. So with that said, I guess that's about it for this specific problem and this video. You're welcome to follow up my YouTube channel to practice more problems. So with that said, I guess that's it.